So, to find the volume of the solid that is going to be created by the region bound by the line y equals x squared and the line y equals x, and then rotated around the line y equals 2. So when we rotate this object around the line y equals 2, it pops up here. This is making a solid, and cross sections of this solid will be a circle. So the larger circle outside will look like this. And inside, since there's an open space here, here's the inner radius. And so this creates a washer. So this washer is what we need to find the area of. So to find the area of this large washer, we're going to have the outside radius minus we got to find the radius of the circle, the red circle, and then we're going to subtract out the blue circle. So here's what this washer looks like, with this being the outer circle with the red, and that's being created by the line y equals x squared. And the inner circle is going to be y equals x. So we've got to find the area of the outer circle minus the area of the inner circle. So again, the area of the circle is pi r squared. This is the radius of the outer circle. And here's the radius of our inner circle. So now we need to find out what the measurements are. And the radius is the same as the length. So what is that length? We are going to integrate just like we did with area. So we are going to subtract. We're going to go from the top here down to the bottom like normally. So we're going to do our outer radius first, because if you think about it, if you have the area of two circles and you want to find the area of the washer, right? So the washer is going to be the area of the big circle minus the area of the little circle. And the area of the big circle is pi r squared. I'm going to use a big R for the area of the big circle. And the area of the little circle that we're going to subtract out is pi little r squared. And I'm just going to use a little r for the little circle. We can take out this pi because that makes the equation much easier to put inside of our integral. And that leaves us with big radius squared minus the little radius squared. And that is the area of just this washer. So it's the area of one washer, but we need an infinite number of washers between 0 and 1. So to get our volume equation, right now we know it's going to be pi on the outside. We're going to find an infinite number of circles from 0 to 1. And we're going to have r squared minus r squared, so big R squared minus little r squared, and then dx for that measurement to make it volume. So let's find big R first. All right, so big R, we're going to go from the radius. Let's do this on the graph. So we're going to go from here down to here of one circle. That is going to be big R. So to get this length, right, so this is the length of the radius, big R, we are going to subtract 2 from this curve. Now 2 is a larger number, so we're going to go first. So big R is going to be 2 minus x squared, and that will give us this first length. And then little r is going to be inside here, and it goes to here. So little r is this little one right here, and that is going to be also starting at 2 minus x. So these are the lengths of the radiuses. This is big R and little r. So now to put our volume equation together, volume equals, our pi is on the outside because it's the area of our circle. We're still integrating from 0 to 1. And we're going to do big R, which is 2 minus x squared. And that is squared, radius squared, minus, and then we're going to do little r squared. And little r is 2 minus x, and then dx. So then this is how we set up the volume formula, and once you integrate this, then that gives you the actual measure of this solid. Now, we're going to take the same exact region, but instead of rotating it around y equals, or the x-axis, we're going to rotate it around the line x equals 1. So when we revolve this around the line x equals 1, it is similar to revolving it around the y-axis. So this time we are going to be doing the volume and integrating in terms of y. So that means we're going to need dy, and then everything has to be in terms of y. Your limits have to be in terms of y. Everything else is going to be the same, except we're integrating with respect to y, which also means we need to solve these equations for y. We just need to solve the equation y equals x squared in terms of x. So to do that, we take the square root of both sides. So if we take the square root of both sides, don't forget it's plus or minus. So x equals plus or minus the square root of y. But if you notice, our solid does not have the negative part. So we do not need the negative part. We just need x equals square root of y. So again, we want to put all of these equations in terms of y because we're integrating with respect to y. We don't want to have x's in here in terms of y. Okay, and this is supposed to say x equals 1. So sorry. We're revolving around the line x equals 1. So as we're revolving around the line x equals 1, we make a solid object. And let me kind of draw what this looks like. So we have an outer circle here, right? And then we have an inner circle. It goes from here to here. Again, making another washer. So once we've revolved around the line of x equals 1, we just need to find the measure of each radius. So it's a little different this time. If you notice, we have the outside radius. And then this is the line, x equals 1. And then we have the inside radius. So this time the inside radius is going to be our red equation, y equals root x. So let's draw this on the diagram as well. So here's our first one, and here is our second radius to the red. So we're going to find the area of the outside circle, again, minus the area of the inside circle, and that will give us the area of one washer, which we can then put into our volume formula. So we were looking for this first. Let's do the big outside R. So again, the area of the outside circle, so pi r squared, minus the area of the inside circle, pi little r squared. So then we can take out the pi, and this leaves big R squared of the large circle minus little r squared of the small circle, and this gives us the area of the washer. So we can put that area into our volume equation. So let's go ahead and put the pi out here. And then this is going to be our area of one washer. And then the dy, and now since we're integrating with respect to y, we need to pull our a and b, our bounds, off the y-axis. So we're going to go from 0 all the way up on the y-axis to 1. So those are our limits. So let's get the length of the radiuses now. So the length of the blue radius, if you notice, is going to be 1. And remember, we always go from right to left because we're subtracting. It's actually going to be squared, so it doesn't make a difference. But since we've done this with area, it's just easier to keep it the same. So we're going to go this way. So the big radius is going to be 1 minus y. And remember, it's got to be in terms of y. And then our little radius is right here, or on the diagram, it's right here. And so our little radius is going to be 1 minus, and now we're going to this equation, which is the square root of y. So now that we have our two radiuses, we can put them in our radius equation. So don't forget, we're going to do r squared of the bigger outer radius minus r squared of the inner radius. So that gives us 1 minus y, and don't forget it's radius squared, minus the inner radius, which is going to be 1 minus root y squared. So this is what we're going to find the volume. This entire thing is the volume. Remember, it's the area times the third dimension. And then once we integrate this, we will have the value for the volume of the solid. Thank you.